Remember how we said we would explore that crazy little thing called the wave-particle duality of light? Well, let's start with one and then we'll move to the other. First, we'll look at light as a wave. You can ask any scientist today and they'll tell you light can behave both like a particle and as a wave. But how do we know this? Where is the evidence? Well, the evidence comes from Thomas Young's double-slit experiment. But prior to Young's double-slit experiment, there were two competing theories over the physical properties of light. What was light? And what was it made of? On one hand, you had Christian Huygens, a Dutch astronomer, physicist, and mathematician who first suggested in 1678 to the Paris Académie des Sciences that light was a wave. Huygens intended to uproot and replace the previous belief put forth in 1637 by French philosopher and mathematician René Descartes, who claimed that light was made of tiny little particles called corpuscles. Huygens' rival theory was supported by none other than Isaac Newton, who claimed that Descartes' corpuscular theory of light was correct. He was so adamant in his beliefs that he sought to disprove Huygens' theory that light was a wave. But, as it would turn out, they were both somewhat correct. And this conclusion came as a result of Thomas Young's double-slit experiment. So, what was Young's double-slit experiment? In order to understand the results of this experiment, we first need to rewind and review our understanding of waves. We know that when the surface of water is disturbed, the water forms ripples, and as the ripples extend outwards from their source, they might interfere with other nearby ripples. But when the sources of the ripples are synchronized, we get a specific type of interference pattern in the waves that are radiating outwards. Some parts of these interfering waves combine if they are in sync, resulting in what we call constructive interference, and others cancel each other out if they are out of sync, which we call destructive interference. But why is this relevant? Well, because that's exactly what Thomas Young observed when he aimed a beam of light through a set of extremely tiny slits. When light is aimed through a single slit, what image shows up on the screen in the back? And how would this image change if there were two slits instead of one? Thomas Young's findings showed that this is what you would see on the screen when there was only one slit for the light to pass through. And this is what you would see when there are two. So, why were we getting so many of these bright fringes when there were only two slits the light had to pass through? Well, because that's what waves do. So, this was the evidence needed to show that light actually was, in fact, a wave.